What is the purpose of the functions? Why we need a functions or methods? What is the reason behind it? Why do we need a function?
The function is nothing but a lambda expression actually. So basically this lambda expression do some calculation, so we can pass the function as a method parameter also. So
Mm-hmm.
this is like higher order functions. And method is just like our Java method.
Mm-hmm.
If we take some parameter, we do some operation on top of it and we return something.
Okay, so the functions, okay, it's not like lambda expressions. It's not only lambda expressions. Yes, lambda expression also is a function, I can say, but functions uh, where we can, I can say, we will not be declared with using a def command. For methods we will use a def def command, and methods and functions are both the same. Okay, both are similar, but the slight difference is that when you declare a function, you really not required to declare a def, declare with the definitions, right? But when it comes to a methods, we will declare with the def, right? And we'll give some list of argument, a method name and list of arguments, and we'll start writing that. Okay, I mean there is no major difference. The main purpose of the method or functions is slice your bigger problem, right? So you'll be having a bigger problem, so you cannot go ahead and sit and write everything in a single file or single method, right? So what we will do, we will slice it, we'll make it a small breakable into small problems, and we will write the code for that, like a bunch of statements we will write, and we will give a name for that bunch of statements. We will give a name for a bunch of statements, then we will start making use of it. And as one of our colleagues said, that so code reusability, we can also make reuse of the code, right? That's the main purpose of the functions. Break your bigger problem into small problems using methods or functions, then start solving the problem, right? That's where the functions come into picture. The another advantage is code reusability. So if you write one function, maybe that function can be make use of in other places as well, right? Any doubts from last class, like functions we have discussed about, um, methods, and we have seen different ways of declaring the methods and different parameters, named parameters, default parameters, and we have discussed a couple of things. So does anyone has any doubt? Does anyone has any doubt? Any doubt about functions? Any doubt about functions, functional methods? Let me share my screen. Scala functions. Yeah. So now today we are going to see higher order functions. Higher order functions. What is the higher order functions? What is the higher order functions? So higher order functions are a functions, a method. A functions are a method which will take a method as an argument, or which will return a method as a value. A method as a value. Such kind of functions we will call higher order functions. Higher order functions. So I think we have written here something here, you can look at here. So we can pass a function to another function as a parameter, or a function also can return a function as a value. We can call these kind of things higher order function. What we'll call higher order functions. Not only that, from functions we can create a composition like one function to another function. We can create nested function inside the function, right? So we will see couple of things today, so we'll be discussing about them in detail. Let me give a heading saying that higher order functions. Where is the cursor? We're going to discuss today higher order functions. As we know that Scala is a functional programming language, here the functions are first class citizens. First class citizens, what does it mean? It means when we say first class citizen, what does it means? Like oh, oh, we know the difference, right? What is a first class citizen, what is a second class citizen, right? The first class citizen means that they'll give a high priority for that, and the second class citizen, if you say second class citizen, so less priority will be there compared to the first class citizen, right? So here in this case, the functions are in the Scala, functions are first class citizens. And when it comes to the higher order functions, when it comes to the higher order functions, these are all first class citizens. These are all first class citizens. So let's look at it and try to look at, I mean, what does it mean, you know, how we will write these first class functions in this. So we know that how to write a normal functions in Scala. So we have seen in the last class by using def keyword, and we'll give the method name, and we'll pass the parameters, right? So what is the difference between the normal function and a higher order function? So the difference between the normal function and higher order function, so people may ask you in the in interviews, guys. So where in the normal functions the parameters will be either value or either values, right? We will be passing a parameters to a function. But when it comes to the higher order functions, the high these functions these functions will take higher order functions. These functions will take a function as a parameter. A function as a parameter, or this function may return these functions may return these functions may return another function another function these functions may return another functions. So such kind of functions will call higher order functions. Higher order functions. So these functions are, as we can create lambda expressions. We can call lambda expressions or lambda functions, or we can say anonymous functions. Anonymous functions, where we can call anonymous functions. We will talk about these anonymous functions and all, okay? And also we have something called closures, and we have something called currying. We have something called closures. We will talk all of them one by one today. One by one today. Okay, let's look at here. So as I explained, a function will take so I think everyone knows about the anonymous functions. We already seen in the a couple of classes before. Let me explain the anonymous functions first, but since it is very easy to understand and so easy to write, this anonymous functions itself we can call a lambda expressions. We can call a lambda expressions as well. Okay, let me write it a very simple way, and let me show you that how we will call anonymous functions and how we will execute them. So let me show you to it. We have done a couple of times before. We have did it. Wait, it's actually moved. Yeah, look at here. Anonymous functions. How we will write anonymous functions? The function will not be having a name, guys. Very simple way. To tell in a very simple way, a function will not be having a name. Let me show you here. Let me show you here. You will write a function and you will write another variable. We'll use a rocket. This will call rocket. We'll use rocket and we'll specify something here. And we'll specify something here. This kind of functions we can call, this type of functions we can call anonymous functions. So anonymous functions. So these will be, you can write like this. You can write like this. These kind of functions we can call anonymous functions. Let's look at them. Well, we already seen this in the last class. Okay, int int. So it takes two arguments here, and we will do x plus y. We're doing x plus y. Here we have created a lambda expression, right? Here we have created a lambda expression. Now when I want to add these two numbers, what I will do, if you just press add, what will happen? It is telling that it is expecting two arguments, and it will give you an integer, which will give you an integer. So let's look at here. I'm going to give some arguments here. It will return you, it will return you 30. It has actually has it is actually executed as a function, executed as a function. So here we can still simplify these functions. Still we can simplify these functions very simple way, like we can call them. Okay, is that clear? The font size is clear? Yeah,
Yes, Vera.
yeah. So now here, so still we can simplify these things by using placeholders. Placeholders, or we can call as an underscore symbol, where we can will make use of the underscore symbols. Let me declare here something like val subtraction, where I can say I'll be declaring one variable with the underscore, and I can specify which is a int. I can do a minus here. I can write one more placeholder underscore int. underscore int. So I really no need to specify x comma y, and they will do. I can directly make use of this. So they will understand that when I pass a parameter, it will take the first parameter into first expression, I mean first placeholder, and the second parameter into second placeholder. Look at here. These type of functions will call anonymous functions. This type of functions will call anonymous functions, where we can make use of them. So these anonymous functions, right? These anonymous functions, sometimes we will declare inside another function. Inside another function. Those such kind of functions will call higher order functions. So we will see them like a map, a flat map, filter. These are all internally uses anonymous functions. Internally we'll use anonymous functions. Those functions will call higher order functions. Those functions will call higher order functions. Is that clear, guys? Any doubt here? Any doubt here? Okay, so here in the Scala, so someone was asking me sometime before in the previous class, so sir, I have a function like this. I have a function like this, which will take two arguments. Two arguments. I will write what I will do. I will write in the multiple lines, sir. Will it work? If I write a multiple lines, will it work? This was the question he was asking me sometime before. So maybe he might have saw here or there, and he was asking me, sir, I have such kind of function. I want to sum them. I want to sum them. I'm writing into multiple lines. So Scala, since Scala returns the last expression, now here what will happen? Here it will, this function mul, will it this expression will execute or not? This expression will execute or not? So when if we write such kind of multi-line expressions in Scala, we need to follow some kind of rule. Okay, it is not actually a rule, I can say it is a kind of syntax. So when I do like this, it will give me an error. It will give me an error saying that a pure expression does nothing in the statement position. Multi-line expression might require enclosing the parenthesis. This is a rule, enclosing the parenthesis. So what we need to do, so if it has to work, if it has to work, either we need to start with such a way that you can do like this. Your operand and operator, make it first operand then operator, then you can keep a next line and the next, you can keep next line with another operand. Since it's a binary operator, we can do like this. This is valid. This is valid. So when you write a multi-line expression, you make sure that your operator comes in a single line before an operand. Single line before an operand. I mean after an operand, I can say. Or okay, let me send some values here. It is working fine. So similar kind of, when you want to do similar kind of expression, or when you want to do similar kind of operations, what we need to do here, other way multi-line expression, as per this warning, we can declare like this also. We can declare like this. Either you can keep it in a single line, or you can keep it in a multi-lines. Right? Then it works successfully. The multi-line expressions. The multi-line expressions. So it will work in this way. Any doubt here? Any doubt? Okay, now let's see these are all called anonymous functions. And let's see other one. As I said, a function can send a function, not this one. A function may take another function as a parameter. Let's see that how it will work. Let's see that how it will work. Okay, very simple example I'll take here to make you understand. So let's look at, I'll be writing two functions, two different functions. I'll be writing two different functions here. There's a cursor. I'm writing a definition of defining by definition to write let's say multiply by 2. I'm going to multiply by 2, which will take an argument, what it will do, it will take an argument, then it will multiply by 2, or you can say multiply by 4, whatever it is. So I'm taking just a simple example to make too easy to understand, which will return an integer, anyway, since it can take infer. So what I can do, I'll just say here, say whatever the x you are taking, x into 2. This is one function, so I'm writing another function, def I can say a simple name as a function as a parameter, as param. Here, look at guys closely. Here I have one argument. I'm taking one argument, and I'm taking one function. The most important thing here, I'm taking one function. This function this function returns, or this function evaluates. You can take any value. And it may return something, it may not return anything, so that's up to us. So I am taking unit here and return it. Here we are calling a function, we are calling a function okay. Since you are not returning anything, it will not display any value. To make it display, what we can do, either we can return the value here, or we can print here itself. Look at guys here, this is the function. I have written one function, and here it is taking a function as an argument. So how can I say function as an argument? Let's see that I'm going to call this function. So when I call this function, we will understand how it will work. When I call this function, we will see that by calling function as param, I'm calling this function by passing a value as 100, comma, multiple by 2. So the result will be 200. I'll show you that. It will print result will be 200. Let's see that the same program we will be writing, and let's see how it will work. Let me execute in the terminal, then I'll execute in the program Eclipse. I will be writing the same code in the Eclipse. First you should define a function multiply by 2, and which will take an argument. The argument is x, and what this will do, this can return int, here x into nothing else. Okay, and I'll be defining the next function which will take an argument and function. function which will do an operation, that can be any operation, any value. So it will do some operation and it will return any value here, and it may return something, it may not return. If you, it totally depends on you. So but I am not returning anything here. Here what I will do, I'll call this function. So we have to print this something, right? Println of function, so display some value. Done. Now you look at here, the function has a parameter x and it is taking some function, a lambda expression. It is taking some lambda expression, right? Look at here, I'm going to call this function now. Function as a parameter. I'm going to pass 100 comma multiple by 2, multiply by 2, so 200, multiply by 2, which is displaying 200, so I pass another function call. And this parameter is taken as a function to this. Look at here, I will write one more. So here what exactly happening, let's look at here and write it the same. Okay, let's look at here how we will write the same in our Eclipse. We create an object, as param demo. Again your main method, sm as your main method, and before main method let's define a method. Define a method and which will do some expression, and define another method. Which will take only here. We're just printing, nothing else, just printing this by calling another function. Okay, now this function, call this function by passing some val argument along with the by to another function, along with the by passing another function as an argument. So what is happening here, so when I execute this, it will go and execute this function as param, and this will take a 500 into x variable, and it will take the function into this multiple function name into this. So this function name actually executing a function. So here it's f will become a multiply by 2, and the parameter, this will become a 500. It means actually we are calling a function. It is actually treating as by 2 of x, now that is getting called, then that is getting, as soon as the method is get called, this statement is getting executed. That is what happening in this, 1000. Any doubt? Any doubt here? So this type of functions we can call higher order functions. This type of functions we'll call higher order functions. Any doubt here? Okay, so it means here a function who takes the function as an argument is, or who returns a function as an value, we can call them as a higher order functions. So let's take a simple example, guys, which I like to explain you, which I really know feel easy to explain those functions. Okay, for a simple example to demonstrate that higher order functions, so I really like that to give. So look at here, I'll be writing some set of functions. So let's look at, I'm going to do a summing between the two values. Let's say I want to sum between two values. Look at, guys, here this cursor. I want to sum in between. Let's say I have given 5 to 20. I want to do a sum between these two numbers, 5 plus 6 plus 7 plus, like that, and so on. So how we can achieve that? So you guys might have heard about the recursions. We'll have a separate session for the recursion, guys. So recursion and tail recursions, we'll talk about them. So how we will write a recursions and how we will write the tail recursions, we will discuss very detailedly later. But let's have a simple discussion. Recursion is a function calling itself is a recursion, like iteration. It's a kind of iteration, iterating. How we will iterate? You will be keep going, you will go keep traversing, right? Here also a function will call himself, right? So multiple times a function call himself will call as iteration. So that, so sometimes the calling himself is may become stack overflow exception. What does the stack overflow expression? So let me just introduce you what is a recursion, then I'll take you through this example. A function calling himself is a function. The best example will be saying factorial, right? So what the factorial will do? We'll be doing a best example as a factorial, right? We will write like this, right? What is happening here? It's not 0, it should be 1. If it's 0, all the value will be 0. It should be 1. A function calling himself, this function calling himself, a function calling himself, right? This kind of things are factorial, and this will call as a base condition. You should have a base condition. If you do not have a base condition, it will go infinite. So how it internally happens, right? So you will be having a stack. Okay, you will be having a main method first, then main method you will call a fact method. This fact method again call himself fact. If you don't have a base condition, again he will have call fact, again he will. So this stack is keep maintaining, again he'll call fact, and so on. So the stack will have some memory, okay? If this function is keep going like this, what will happen? In certain point it will overflow, that is called stack overflow. That's called stack overflow exception. We'll be seeing this. So if you, since you didn't handle your function calls properly, so we will lead to stack overflow exception. Okay, so I'm not getting into very detail here, so we will see them in the later sessions with a dedicated session for that. Let's see here. Let me explain the higher order functions very simple way. Okay, so let's say I want similar kind of problem statement only. Here I want to sum between sum between 5 to 10. So like it should be work such a way that 5 plus 6 plus 7 plus 8 plus 9 plus 10. This is my problem statement. This is my problem statement. How will I do this problem statement? How will I solve this? Very simple. This problem statement I'll solve such a way that this is just a point, okay, not the rocket. Okay, I will define a function, and I have to take two arguments, starting point and ending point. Starting point and ending point, which will return integer, because sum, right, total sum, right? Then I need to write a base condition. Okay, the base condition, if I don't have a base condition, I will end up with a stack overflow exception. So before writing a base condition, let me show you the what will be my actual logic. The logic is whatever I take a start, let's say start, whatever I take a start plus 5 plus 5 plus, I need to increment the 5, right? I need to increment to the 5 to 6, right? I need to increment to 5 to 6. Some nums of so the start has to be incremented. The start has to be incremented. Start plus 1 comma, let it be the 10. The end will be always same. End will not change. End will be always change. But if I do this, I may end up keep increasing. My number will be keep increasing. If I write like this, it will throw a stack overflow exception. So why it will throw stack overflow expression? Very simple. Look at guys here. My starting is 5. Okay. Now 5 plus, I'm passing 5 plus 1, 6. Here I'm passing 6 and 10. 6 will come here. 5 is already holded. 6 plus, again here sum, 7, 8, 9, 10, 11 and so on. There is no base condition. It will be keep increasing. So when to stop it is. When to stop? There should be some condition, right? So there should be some condition. So the condition is when I take this is a end point, this is a start point. When I take this is an end point, this is a start point, this should not be greater than this. So that's where I will write my base condition. If a greater than b, you just return 0. Else, then only do this expression. Then only do this expression. This call will call as a recursion function. I hope everyone is able to follow. Any doubt here? Any doubt here? How we will write a recursion? Let me write it here. Higher order functions demo. Higher order functions demo. Okay. Here I'm defining a function def sum nums summing the numbers, which will take x int comma y. I can say start. Okay, let me give a proper name. Start and end, which will return again integer. Okay, here as I shown you the base condition, start should not be greater than end. The start should not be greater than end. If that is the case, you return 0. Else you do start plus some nums of start plus 1 comma end, or you can give semicolon or not, end. So what is happening here? What it is happening? This is a recursion call which I have written. I have a base condition. It is well, there is no error in this. Okay, let me show you very simple. Let me execute. Okay, before executing the whole function, let me execute in this terminal. Okay, some nums of 1 comma 5. Look at here, guys. 1 plus 2 plus 3 plus 4 plus 5. 1 plus 2 plus 3 plus 4 plus 5. Right? So 1 plus 2 3, 3 plus 3 plus 3 6, 6 plus 4 10, 10 plus 5 15. The answer is correct. Right? So similarly, this is for the summing the numbers. I want to write something called cubing. Cube the numbers. Sum of cubes. I can say first let me write a cube, then I'll write the sum of the cubes. Okay, let's write cube cube power of 3 power of 3. Let's take a simple example. So I am defining 3 different functions here. Later what I'm going to show you, I will be writing 3 different functions, and I will be showing you in a single function we can call all of them. We can call all of them. So you can write in a single line. So you're really not required to write like this. Okay, x x x cube of sums. Now I want to do sum of the cubes. Now I want to do sum of the cubes. I want to do sum of the all cubes. So def sum cubes, and where it will take a number. Let's say x int and y int, return int. Here I need to do sum of the cubes, right? So here also we need a base condition as similar as that. If x, if the greater than y, if x greater than y, return 0, else we can write in a single statement, or let me write in multiple statements. Else we're doing a summing, right? Cube of sum. So for each value we need to do a cube of sum. Cube of x, cube of x plus next value 6, like 6 will come, no, the same. So you have sum of cubes, sum cubes, where you need to specify x has to increased and y should be same. Y should be same. So y is not going to change anything. Done. Here what is happening? Sum of each number cube. Sum of each number cube. Let's execute this. Sum of each number cube. Sum cubes of 1 comma 3. 1 comma 3. Because guys, 1 cube plus 2 cube plus 3 cube. 1 cube plus 1 cube means 1. 2 cube means 8. 1 plus 8 9. 9 plus 3 cube means 27. 9 plus 27 36. 9 plus 27 36. Is this clear to everyone? Guys, if you find any difficulty, please let me know. Okay, this is the best example I have found to explain you, and there is one more example to demonstrate the higher order functions. So looks very easy to make you understand. That's the reason I have chosen these functions. That's the reason I have chosen them. Okay, Let's define one more function quickly, but the writing functions itself will take so much of time. Okay, let me define one more function here. This time we will do the factorial. So let's write the first factorial. Def fact of take x, which will return integer again. Okay, here the factorial, right? So here also we should have a base condition. X, if it's a greater than 0, no, if it's x is less than 1, right? X less than 1. If our x is less than 1, return 1. X equal to 1. If x equal to 1, return 1. Else, what we need to do? We need to sum of factorial, right? X plus fact of x plus 1, or x minus, right? Here we are doing x minus. We no need to give plus 1. X minus of this. Let me test whether it's working fine or not. If it is not working, then it will be a problem. Okay. Fact of 4 plus 3, 3. 3 to 1, 6. Fact of 4. No, wrong, right? Fact of 4. It means 4 into 3 into 2. 24. It should come 24. Why it came 10? Something went wrong here. X plus factorial of x I have taken if x equal to 1. I think I have a doubt about this condition. X less than or equal to 1. Fact of x plus, I'm decreasing the number, right? Let's say I have given 4. 4, yeah, we are doing a plus here. Should be into. Thank you for the quick response. Who is that? Under, yes. Now let's see. It's not x plus, it should be x into. You see this? 24, 6. 120. Okay, working fine. Okay, now I want to do same. Now I want to do the same. Fact of all sum the values. Fact of all the summing the value. Sum of factorials. Sum of the factorials. Sum of the facts. So here also the same, but here fs it. Fact of sum of, and here is this. Okay, so what I'm doing here, I'll finding the sum for each and every I'm finding the factorial for each and every element, then I'm doing a sum for it, then I'm doing a sum of it. Okay, now if you execute one by one, we might have understand I'm doing this here recursively summing each and every element. Here I'm doing a cube, here I'm doing a cube of each and every element and doing a sum, and here I'm doing a factorial. Here I'm doing a factorial. I'm doing a factorial of sum. Factorial of sum means one. If I give 1 comma 3, 1 factorial plus 2 factorial plus 3 factorial. So the total value whatever comes, it will come here. So now So now we have written this way, right? What we are doing a sum and all those things. So all we can write in a single function, and we can pass these functions to that function. What our intention is, write one function which will take these function as an argument, these functions as an argument. Based on the function call, they will execute. Okay, let's look at here. I'm going to give a simple example. Def um def, let's say sums. I'll say sums. I'm doing all of sums, right? Let's say all of sums, and let me take a function here. Let me take a function here. Function with an arguments. I also need a function with an arguments, right? It will return int. It will return int, and along with this, I need an arguments. So I need x int, int y, and int, which will return totally an int.
Yeah.
Yeah.
F means the function, right?
No, you can declare any name here. It's not like it has to be always f. So I'm just giving you f to reference that it's a function. You can give z.
Okay, sir.
You can give
Okay.
y, whatever it is. But y already have to make use of it. It's not the fixed keyword or something.
Okay, okay, Vida, thank you.
Yeah. So here, so what I'm going to do, same condition, guys. So the same condition, let me copy paste here, but a little change, a function of little change here. So here you should take sums, and we are calling this one, and here no, this one is little change. Here I need to pass a function, again a variable with x plus 1 comma y, x plus y comma y. Here I am passing three parameters since function, and one incremental, one endpoint. Okay, correct. So let me do this, and now this is a function which I have written, right? So now what I need to do, I need to pass these functions to this. I need to pass these functions to I need to pass those functions to this sums function, right? How, look at here, the same thing whatever I have written here, the same thing I'll be writing in the rewriting here. So any confusion here? Very simple, guys. So what I'm trying to do here, I'm writing a different functions. We have executed them, how they are working, right? The similar thing we are writing with a higher order. Very simple. We are writing with a higher order. We are writing with a higher order. So this is the higher order function. Okay, one function only which will take another function, and it will return your result. It will return your result as a value. It will return a result as a value. That's what I'm doing. So these are the individual functions. So these are how it will work. We have seen these are individual functions. Okay, no doubt about it, they are working fine. Now these individual functions, instead of writing individual functions, I'll return one function which will take a function and arguments. Based on that function and argument, it will act. Let's say if I pass a cube here, if I pass a cube here, what it will do? Cube of all sums. If I pass a factorial here, it will act as a factorial. If I pass a sum of numbers, it will work as a sum of numbers. So this function is a higher order function. This function is a higher order function. That's what I'm trying to show here. This is what I'm trying to show here. Let's look at, I'm defining another function. I'm defining a simple function here. The sum ints, whatever we have taken sums. So the same function I can do sums to sum nums to the same function. Okay, the same function I'm writing here such a way that which will take x int y int. This was the syntax of my previous function. Here I am assigning it sums of what I need to pass here, your function name, right? First I need to pass here function name, then arguments, right? So let me pass here x, which will return x, comma x comma y. Let's do it. What will happen
Here I have to pass function name, right?
here? That's what I'm here. Which function name I need to pass? So here we need to pass function name sums, sum nums.
But some num is expecting.
Let me define another function. Function, let's say uh, x y z, which will take an argument, say a colon int, which will return an int. Let me say this xyz here. No, that's what I'm thinking. Why should I pass this xyz here? What is the function will call this? Let me 1 second, guys. Let me check this. The terminal. Okay, it is expecting a function. Okay, a function which returns this. Okay, a function which will take an argument which will return integer. Okay, that's the reason. Okay, the next one is I define a function which will take an argument which will give the same argument. That function I'm passing it here. Now let's sum nums two of 1 comma 3, 1 comma 3. No, it's wrong, right? Actually,
Birla, what is the meaning of this line actually? Come to the,
this line you're talking about.
yeah, means why you are assigning actually. See, you have defined a function telling that this function will take two parameters and
One
you are
second,
assigning with another function.
1 second. I'll just send it. So type mismatch. Sums 2 have taken where, so already have declared the sums. The meaning of this is, okay, when I call this function, it has to call the sums and it has to take an argument and it has to perform this summing. Like let's say if I say sums 1 to 2, 1 to 3, it has to take 1 plus 2 plus 3 and it has to return it. So that's something I'm missing here. Let me check. Some queues, some nums we have, right? We already defined some nums is already there. Okay. what is our sums will do, it will take this. Okay, here some nums, comma 1 comma 3 function sums. It is a type mismatch. It is an int and int. Let's take the function correct only. Then let me specify this. Let's take int and gives an int. What it is trying to do, it is taking this. The condition is wrong. The function condition is wrong. This is wrong. X greater than y, then 0. It is 0 in this case. X greater than y, one comma 3, 1 plus 2, 2 plus 3. No guys, this function is wrong actually. This function is wrong because 0 into I'm doing, right? That's the reason it is giving 0. It should not be 0 into. It should be 0 plus. It should be 0 plus. This function is wrong. Because of that it is giving me error. Okay, since we have copy pasted from here, we supposed to copy paste from here. We copy pasted from here, that's the reason. Let me execute this one more time. Okay, now execute this. Yeah, now look at here. So now when I'm calling a sums, okay, look at here, I'm calling a sums by passing a function name, and some parameters, right? Let me show the same thing. Sums2, sums2, sum nums2. Okay, here let me I'll explain why it is. Okay, now I'll explain this. Look at guys here. Yeah, so what it is happening, do you guys remember anonymous function sometime before? So what we have done in anonymous function, val val x, I have done like this, if you guys remember, and this function is assigning, right? And this is doing x plus y. Do you guys remember? Actually, it is a function, anonymous function I'm assigning to a variable, right? I'm assigning to a variable, right? Similarly here, I have declared a sums2, which is a sums2, which is assigning another function sum, when I'm passing that sums, when I passing that number, I mean that function. Now this function, what are the arguments you pass to this function, right? That arguments will go to this function by explaining, I mean by specifying your function name. So if I want to do a sum, what is happening here? It is taking this number and it is calling a sum of x plus y, sum of x plus y. Let's look at here. So I'll be executing the cube. Okay, now you'll understand. Because your doubt is clear. Is your doubt is clear? Because of the function name, it was, I mean the function uh,
Yes, yes, yes.
logic
It's
was
like
wrong.
taking that. Yeah,
Yeah,
it's like taking the parameter from there and passing it to this function.
exactly. So because of this logic was wrong, it was failing. So now the logic is correct. So I can say this is instead of saying num, let's say num. I'll say num here. This is blind simple number. Okay, I'm defining a cube now. The sum of the cubes. If anyone is confused, please let me know. Okay, cubes. So it looks a little tricky, but it's very easy. Okay, the only thing is, instead of writing a different functions and calling for the different logics in one function only, you write of all the logic. This logic is same, no? Everywhere this logic is same. If you observe, everywhere this logic is same. If you look at, except the factorial, but sum of the factorial logic is same. Plus sums. Here also plus sum. Here also plus. So everywhere logic is same. Instead of writing multiple times the same logic based on the your function, let's say one time you have written the same logic for the factorial. One time you have written the same logic for the cube. One time you have written the same logic for the number summing the numbers. So instead of that, you write one function which will take a function based on the what the operation you want to do. So look at guys here. So I'll wind up by explaining this. Okay, then tomorrow I'll show you one more example to make you very much clear. So what I have done in the above example, first one, summing the numbers. So I have written one logic. So 1 to 5 numbers I want to sum, I have written one logic. Next what I have done, some cubes of sum. Same here also, 1 cube plus 2 cube plus 3 cube. Here also same logic I have written. The third one, factorial of sums. Each factorial, 1 factorial plus 2 factorial plus 3 factorial. So this logic is same, 1 plus 2 plus 3 plus, this logic is same, right? But I have written three different ways. Why? This is factorial of sums, this is a cube of sums, this is a normal number of sums. So instead of writing three different logic for the same business, so what the Scala is telling you, write a higher order function. Where is the cursor? Yeah. So you write a higher order function which will take a function, I mean, you write a higher order function which will take a function and you give a parameter xyz. So based on this function, whether it is a number function, it will work. Whether it's a cube function, it will work. Whether it's a factorial function, it will work. Based on the function name you pass here, it will work. Everyone is clear what I'm trying to do in that example? Is everyone is clear what I'm trying to do there? Try to understand, guys. This is more important. That's the reason I'm keep asking you guys. Okay, tomorrow I'll also show you one more example. That example I'll show you in a very simple way. One time I'll do a, where is the cursor? One time the same higher order function. Tomorrow I'll also explain you one more time. Plus operation, into operation, minus, min and max. These all three operations. To do all these three operations I need to write a three different functions, right? Three different functions. So in higher order functions you don't need to write all these five different functions. I will write only one function, but I'll pass what operation I have to do. So based on that my function will work. That is called higher order function. Is that clear, guys? Yes, no?
Yes, Biraj.
Yeah. So others, I'm not hearing from others like who are not from the the programming background. Ankit, Anisha, Bharat. Okay. So
Yes, Viran.
okay, I'll explain this one more time tomorrow. I know that little confusion, so not to worry. So tomorrow I'll explain one more time. So with a simple example, it looks a complex example to explain for non-programming people. So tomorrow I'll take another simple example like adding, subtracting, multiplication, and min and max kind of thing. Then we will pass that to a single function. We will explore on that. Is it clear to everyone? Yeah. So let me finish this. I don't want to leave it like this. So let me finish this where cubes 2, let's say here I will write a function where I need to take a x int comma y int. I just say here I need to do a cube of two numbers, but I have already have a sums. So in this sum I'll specify cube comma x comma y. So now this sum function I no need to write a logic. So already I have predefined a function. This cube what I need to do, it will execute here. Let me write another one. Factorial, right? We are writing a factorial. So sum fact 2 fscts 2. Why I have taken 2? Because since I already defined the num before int comma int assign sums of, you just need to specify fact of it, fact comma x comma y. Why it is giving error? Why it's giving error? Maybe some mismatch, type mismatch. Method some fact is defined twice. Okay, that's what the function name 2. That's it. That's it. So instead of writing these many lines of code, I'll write only this lines of code. So based on my parameters, I'll pass it. Based on my parameters, based on the requirement, I'll pass. Look at here. I'll be executing the same three different functions I have defined. Now, if I want to do only numbers, I'll do like this. Okay. If I want to do only some cubes 2. Actually, I need to take some cubes 2. 1 comma 3. 1 cube plus 2 cube plus 3 cube. Something went wrong. 1 cube 1 plus 2 cube 8 plus 3 cube 27 has to come. Sums cube 2. Something went wrong here. So that cube function. Let me check with the factorial. The way it works is same. Maybe our logic might be wrong. Okay. So let me say 1 comma 3.
Is it same like currying actually?
Sorry. No, currying
Is
is
it
something.
same like
Currying is something different. I'll explain that. What is a currying? Okay, so I'll continue tomorrow, guys. So what is the why it is giving wrong results? I'll tell you. The wrong results because of the logic. Okay, but the way you make use of the higher order functions, the similar way. Okay, the wrong results is because of the logic. So that I will anyway, I'll fix it tomorrow. Okay, so I don't want to stretch your day, so already people are left. Okay, thank you guys, thanks for your time. So tomorrow also we'll be continuing with the higher order function, and day after tomorrow we'll be seeing recursions, and after that we'll be seeing string interoperability, then classes, from the classes onwards it will be little faster, so you can easily catch up there. Classes, case classes, or companion objects, and what is the difference between the companion and normal object. So we will be seeing all of them. Okay, okay. Thank you guys, bye.